Really excited to be here, especially in Krakow today, actually, to talk about, well, enterprise IT is kind of dead, and long live enterprise IT. It's an interesting story I'm going to present to you, something I've been very passionate about for the past 2 years. So hopefully you all find it interesting. At the sort of the core of this, particularly being to other sessions throughout Devoxx, we heard talks around how to do MVPs, net present values, to do microservices. There's been lots of inspirational talks around how to actually, budget it, organize your teams, and what sort of culture you should have. What I want to tell you is our very personal story, and you're going to walk away with 3 core tactics if you're going to do enterprise transformation yourselves. So hopefully you'll all find it very interesting. So 2 years ago, I was hired. My name is Yves Hwang again, in a company called Statoil Fuel and Retail. My role is Internet Mobility Architect, even though I'm a developer at heart. So 2 years ago, the company realized it needed to bring about change. And it's not too surprising, large corporations are really being pushed and sort of pressed up against the wall. Enterprises are struggling. And by 2020, more than of the 500 S&P index companies will be comprised of businesses that we don't know about. So these are disruptors, these are startups, these are people who can innovate and challenge large corporations. In some way, our company that I work for started to sort of panic a little. So when I first started, we needed a strategy, right? As you would, because I'm an architect, I do strategic things. Some of the strategy I came up with, which is not too surprising, is to sort of evaluate how do we do cost reduction. At the time, we had a lot of vendor lock-ins, and how do we improve time to market? And of course, when you do all of this, you need to support your local business units, and you need to sort of give them a way out and say, this is how you reach new sales and new opportunities, and supporting your own digital channels. Which sort of can be summarized into, let's do DevOps, let's do things quick and ship early, and we do things right, and use open source, you get all of this for free. But it is the same survival tactics that a corporation would use, except for something like a startup or like a disruptor. If you think about Netflix, a company that's born in sort of the cloud age, their ways of building infrastructure or even applications are completely different from something like Statoil, where you have a lot of legacy, lots of monoliths. And something like a disrupting company would be built out of innovations, much like people at this current audience. You guys are all craftsmen and women. You care about continuity. You do things with agility in mind, not so much in large enterprise IT. So honestly, when I had to talk to the business units again about what we're going to do for the next couple of years, sort of told them, listen, you should brace yourselves. The winter is actually coming. There's going to be terrible times ahead. But then, as you know, sitting in Devoxx, you kind of realize the winter, in fact, is already here. If we're not doing something about this, your business is going to go out of business, even for a large corporation. So I'm going to tell you exactly how to get your company out of this mess. But before I do, a little bit about myself. I live in this beautiful country called Norway. It's pretty beautiful and cold. I don't always live there. I actually come from Australia, from Perth. I'm a big fan of open source. Before I started working for these enterprises, which is just 2 years ago, I was working in an open source startup called Varnish Software. Sort of very active in the Varnish community. I still am very active, and very active in the Jenkins community, and often sort of talk in their events. Incidentally, I've been a Java developer for a very long time, but I do like Node. I think the future is actually in Node, so that will mark that one for the record. Most importantly, I'm passionate about DevOps and automation. What I do at work basically is these 2 points. So, coming back to the story. So I work for this company called Statoil. We have presence here in Poland. A little background about the company is, yes, we are being rebranded to Circle K, but we are sort of a large enterprise when it comes to retail, fuel and retail. We span all of Nordics, so that's Denmark, Sweden, and Norway, and all the Baltics nations, as well as Poland, Russia, and Ireland. We're about 2,800 stations strong, and there's about 22,000 employees. And then if you think about our IT portfolio, what would that look like? Is huge. So we're talking about like 800 odd API endpoints existing for legacy systems, and a large array of God knows what systems we procured throughout the decades. It's terrible stuff. So when I first started, that was the landscape. There was nothing cloud-enabled, nothing in the cloud. We had our own data centers and stuff. And I believe I was introduced as the change agent, and this is what I've been doing for the past 2 years, to instill DevOps culture into the company, and this has been a very large part of my life and sort of doing this. And of course, this is based on, mostly based on automation. But automation is really nothing if you can't provide the sort of cost savings you would if you were building microservices and cloud native, and that's what I want to talk about. And last but not least, a change agent really can't call himself a change agent if you're not talking about some kind of transformation. So that's basically what we're going to talk about today, these four points. So coming back to the comparison between a very large enterprise IT, you have processes, you have different departments, you got to do change requests, you're really not innovating very much because you're sitting on your ass and answering emails all day. It's terrible. But if you compare to sort of the characteristic of a disrupting startup, something I used to work for, we work at extremely high pace. Decisions can be made on the spot. We can adapt very quickly. So in order for large enterprises to change, you need to sort of pick up the pace and learn to adapt, or your business will go under, particularly IT. An enterprise is sort of like an old dinosaur. It's going to get wiped out if they don't do anything. And it's quite interesting because there was a talk I just went to today that talked about developers needs to have more business sense. I would actually counter-argue this and say developers or DevOps should really be technologists, creative technologists. And you should remain as creative technologists because that's how you drive innovation, not so much learning how old school business actually worked. So we are about transforming enterprises and adopting the startup mentality. So when I first started, obviously we weren't the first. The first thing you should do, you need to get buy-ins, right? You need to get buy-ins from your business units to sort of convince them this is a good idea. We're going to invest in this. So what better way to do this than to quote someone really, really clever, a bank called ING. Their chief architect actually came out in the DockerCon one year, I think 2 years ago, and said, listen, our competitive advantage is actually IT, and we believe banking is IT, and IT is bank, and they're going to transform how they do banking in ING. We were quite inspired by this, even though we're not doing banking, but we have similar systems. And so the mentality started to change. But before you sort of talk about the real problems, we need to first identify what is an enterprise IT. What does that mean? Are you working in one? I know I am, because there's some very interesting observations. So let's start with some facts, right? You know you work in enterprise when you have loads of meetings, you have lots of processes, and depending on if you are sort of trading stocks in the US, you have the SOX, you need to be SOX compliance. You do MasterCard, sort of credit card or banking, you need to be PCI DSS. And there's a whole bunch of, like, you might have spent the past 5 years doing ITIL, getting somewhat good at it, and only to realize you spend half your time writing emails. And there's so many people that are called managers and management groups and leadership groups, and you count the number of people actually doing the work, is not that many. And that is an interesting fact. So an aging enterprise actually can't do anything, in my opinion, when I first joined. Fact number 2, when you do end up in these terrible meetings, you talk about buzzwords. Some of the talks I've been to also stated exactly this. People like to talk about interesting things that don't really make sense. I'll give you a really interesting example. I was talking to, I can't be too specific. I was talking to somebody, and they were telling me about this wonderful technology called data lake. What the hell is a data lake? When did we have lakes of data? Like, how many swimming pools constitute a lake? And can you have enough data to eventually fill an ocean of data? I'm not entirely sure what this person meant. And I find that it is not just us experiencing this. Open source communities, this is Kelsey and his buddy from Kubernetes. I follow them a lot. My DevOps microservice is going no ops and serverless. Like, oh my God, does this actually make sense? I don't know. Fact number 3, right? So when you do enterprise transformation, this is what your boss is going to tell you. And it is actually true, that your current and your very, very large investments, or we call portfolios, are basically not going anywhere. So you invested in a whole bunch of .NET stuff, whatever. Like whatever it is you have bought is not going to disappear. It's a bit like what happened this morning with the Brexit. Yes, but it's not going to happen right now, today. Fine. So that's kind of the concept. You need to live with this for at least a few more years. How do you get out of these systems? Fact number 4, which is an interesting one as well. So when you eventually find sort of an application, microservice perhaps, that you want to build, and you've convinced the business units, you've done your sort of net present value, you got the buy-ins, and you got your budget, you very, very quickly realize that you can build all of these wonderful things, but then your organization is just not ready for it. They don't understand. They are not cloud native. They don't get it. You can roll things out with Terraform. That's great. Use Kubernetes. As soon as you hand it over to somebody else, they just go, whoa, why isn't this coming to me in an email or a change request? I don't understand. So you have to be prepared for this. You need to sort of educate your people. So the craftsmen and women in this room, it's sort of imperative that you go and educate your peers. Otherwise, you land with this. Fact number 5, which is the most depressing fact, is that whatever cool things you're building out of, like, I don't know, Drop Wizard or whatever, you will be highly dependent on some existing monolith, some existing applications you just simply cannot get out of. And the fact of the matter is, that is you pulling data out from sort of the legacy system, a place where data has been gathering for decades, and there's just no way around this. So you need to have a strategy as to how to deal with this. More often, you can't trust these monoliths, and I'll sort of explain what they are in a second, and how do you deal with that. So, what's a monolith? To me, very personally, I believe a monolithic app is a traditional app. You can call it a multi-era app, an app or whatever that's been living for way too long and should have been shut down about 10 years ago. It's tightly coupled, right? You have sort of your layered architecture. I'm sure it all had a great, sort of made great sense at the time, but it was so tightly coupled. The UI layer could be tightly coupled with business logic, and you've heard like you can have business logic inside your data access layer, which essentially renders each of the layers impossible to switch out. Some of your monolithic apps will be sort of dependent on the technologies that stagnates, right? You get vendors that don't want you to upgrade or patch. They like you working with the, for example, older versions of Java. It's really crazy if you ask me. And of course, it lives in an environment, often the configuration is static. And I'll give you a really good example. Like, if you were to do clustering J2EE, very often each of the nodes have to know each other's IP addresses. Now, how does that work in Amazon? Because that is not an assumption that upholds at all. In fact, you have dynamic IP ranges. And the way sort of cloud-native apps sort of horizontally scales, you can create them as you go along, just does not happen in an old-school data center. And how do we deal with that? And when you do sort of sit down and try and address this very issue, you very quickly realize that you can't decompose any of these layers to anything that makes good sense. So it lacks deployability. And you can't pick up your data center and just move it to Amazon or Azure or Google. It just doesn't work like that. At some point, we sit down and realize, yep, we're pretty screwed. Looks like there's no way around this. We're all going to lose our jobs in IT. This is terrible. But then if you sort of think about how business operates, right? And some very clever people in Gartner came up with this concept, which we kind of liked, is that this is called a pace-layered architecture and a pace-layer sort of approach to how you deal with things. You take a system of records, right? There's a category of system that doesn't see much changes. So this is your ERPs, your CRM, and every sort of giant corporation have this. You may not need to patch them. You kind of leave them alone for a little bit. And you have another category called the systems of differentiation, which is essentially the categories of application that is your existing competitive advantage. What makes your business stand out more than others? And what that might be, you can have a think. How does that apply to you? And last but not least, you have the system innovation. These are your future competitive advantages. Things don't exist yet. You're going to build them. And this is where we found ourselves, found our starting point. We're going to build and transform an entire IT, enterprise IT, from building a whole bunch of system innovations, because number one, it is our future competitive advantage. Number two, it is definitely worth investing in. So once you've done that, you pretty much have a solid buy-in, right? And the next thing you need to do is to find out exactly what you're going to build. You're probably going to build a microservice, probably with a refreshed UI, and you're probably going to productize the process, and it's going to be all very cool and very hipster. And you're going to piecemeal all the things, right? You're going to ship early, and you're going to introduce change that are small and almost undetectable until the change is big and is here to stay. That's what we call piecemealing. It's a bit like Legos. So that's what you want to do. But at some point, you need to take the leap of faith, is what I call. Because there is no going back, right? Once you've solved this, you are going to do this. So, just take a moment and say, we're going to build microservices now. We're going to use Terraform. We're going to use Kubernetes. This is all going to be great. It's going to take maybe 3 months in the beginning, and then blah, blah, blah. And then you need to take the leap of faith. But before you do, don't feel like you're alone, because we're doing it. This dude from Aprenda, Sinclair Schuler, actually I was quite lucky enough to be in KubeCon this year as well. He mentioned that it actually put in some very key options that I'm just going to quote and steal from his slides today for you all. So go check him out. So when you take the leap of faith, you have 3 options. Option number 1 is to convince the business units that you're going to decompose existing portfolio into microservice. So microservice everything. So how would that turn out? Probably not too good. You can't go to a business unit, right, and say, listen, I'm going to reduce costs, right? This is going to be super cheap. But then you're going to have to just hold on for about 10 years and then do nothing, and I'm going to cloud everything. Great stuff. No, don't do that. You need to sort of ship functionalities. You need to convince people you can do this by shipping the competitive advantage, the products. So totally don't recommend doing this, and if you are, you should stop and make it smaller. What we are actually going to do is what I call option 2, and is to leverage, as you build your microservice or your apps or whatever it is you need to do, to leverage some kind of continuous integration server and continuous deployment for the fact that it offers repeatability, automation, and control, right? And these tools and the toolings and the platforms will play into what we call the hybrid architecture, which I will explain in a sec. Yes, that one is a smiley face. That is exactly what we're going to talk about today. There is a third option. I don't know too much about this. This is part of the business of Aprenda, but apparently they have a platform that can do mixed era apps. I'm not entirely sure what that means, but I'll give it a smiley face as well, because it sounds very clever. So let's explore option 2 with CI/CD. I know Jenkins. Let's do this. Okay, so when you start, at least in our company, our very sort of high-level architecture basically looks like this. You take a piece of idea, right, and you want to productize it. You want to build everything on top of the dotted line. And those things are new. You want to put it in the cloud, so cloud-native apps we're talking about. So identify what it is you need to build, make sure it's small enough, Make sure it is a microservice architecture. Make sure perhaps it's built out of one of your favorite Java frameworks. You might run into a situation where you don't have infrastructure that can actually roll out clusters or replica sets of MongoDB. Fear not, try some of the services, right? Because there's cost savings to be made if you were to use them, and in the short term, you can sort of have a fairly decent backup strategy for free, almost for free. And you don't need like a giant group of people running around doing Mongo import and exports, which is really good. And in our case, we're really not afraid of a polyglot persistence. We pick the right tools for the right job. So in fact, we actually use a whole swag of things, Dynamo, Elasticsearch, Postgres. And yes, we do have our MongoDB that we kind of don't tell anyone about, and I look after it. But nonetheless, you essentially will do something like this. What's interesting is if you go to the data center side where basically all your data resides, like how do you then pull all this data out? Some of the things we were seeing is that the application, the enterprise application, had really bad SLAs. Some of the, can't name names, but one of the apps, every time you upgrade them, it needs to sort of go to vacation for maybe a week, which is terrible because whatever microservice you build, it actually gets data from that thing that is half asleep, and that's really, really bad. So we needed a sort of a proxy layer, proxy API layer, that sort of provides some kind of data. Perhaps this is where I would totally introduce caching. You should cache data where you can, and at least give your users ability to read the data and perhaps tell them you can perform updates a bit later. Incidentally, to sort of drive up, this is a very small team we're talking about, to drive up the SLA, we use Elastic Beanstalk for AWS because it is fast, and I'll explain why in a second. And for our on-premise side, we then use Kubernetes because it is basically identical to Elastic Beanstalk somewhat, slightly cooler. So why Elastic Beanstalk? Because what is it? It actually is an EC2 instance running Nginx and Dockerd. That's basically what it is. And it has some sort of magic that controls these things and extensions. But essentially that's what it is. And every time you fire up Elastic Beanstalk, you will get a set of, not a set, one ELB with a bunch of clustered Beanstalk instances. So it's quite good. How you work with it is you would deploy Docker images. You can say, deploy this Docker image, please, and I want 5 instances of this. Or you can give it a Docker file, and there you can sort of tweak what that Docker file is going to do. It is entirely elastic, so that means like you could, you can configure it to go up, to ramp up when the demand is high. And what's nice about it is when the demand is low, you can ramp down as well. So it is a highly available platform, and when you perform updates, by default, you can do rolling updates. So you update one instance inside your cluster without introducing downtime. Most important for me, that this platform is actually entirely hackable, right? You can use EB extensions and basically uninstall Nginx and say, I don't want it to work like how Amazon intends to have it running, and I'm just going to install my own stuff. Yes, you can do that. On the on-premise side, our microservices will live in Kubernetes. And the reason is it has 10 plus years of Google R&D that makes us sort of sleep better at night. But most importantly, it's not built for a single vendor, and it is very community driven. So when you go and try this, join the community, go on Slack. They're a super friendly bunch and happy to answer all your questions. And really lovely people. And it's sort of a mechanism for us to make good use of legacy hardware, right? So we can scale these pods up to the limits of the hardware. Again, like EB, it's elastic, horizontally scalable, and so on. So you have now sort of embarked on the Docker journey. And I can tell you for a fact that if you use Docker a lot and Dockerize everything in production, you really need some kind of orchestration. You really shouldn't be pulling the latest. You really should be still upholding your good versioning control approach and orchestrated according to version number, because there will be dependencies and they're sort of implicit and not very obvious sometimes. The way to think about it is you stacking your containers on top, and it's kind of an accident waiting to happen. And then your next update could break another microservice, who knows? So you need to coordinate this. So how do you actually do this in a very transparent manner that is repeatable? Of course, we're not talking about actually using Terraform, and you should. We're talking about sort of getting code to the containers and make sure it's shipped out in a way that doesn't break things. So we're talking about build pipelines. They're sort of the first-class citizen now in Jenkins. So for us, a build pipeline is a series of jobs that you would execute that provides a repeatable, automated, and a visible platform for shipping applications. Okay? Part of this is so that we can maintain quality. We constantly have this sort of tests that gets executed on every commit, and it runs all our static code analysis. We're bootstrapping the infrastructure as well, so our Jenkins actually have access to AWS, and you can issue EB commands and maybe Ansible to deploy all of this. Inside your build pipeline, you should have a notion of stages, right? You have your environment. So for us, we very lovingly called it test and dev, and the guys didn't complain. We're really happy about that. And it's a notion of you kind of have a kitchen, you prepare your food, and then you give it to the pass, right? The pass is where Gordon Ramsay, if you guys know who that is, will sort of check the food and go, yes, this is okay, and then sends it off to pass, and then you can sell it inside your shop. So it's traditionally test QA prod. We thought it was boring. Why don't we have a test prep and shop? And packaging is super important. I believe packaging is one thing Java developers that just don't do properly. In fact, when they do it, it's wrong. I'll just say it. When you package for sysadmins, we're talking about Debian binaries or RPMs. Really, there's no way around this. Now, Docker doesn't make this a very obvious thing. Docker sort of has a different way to package, and you can sort of dump your jars there, you can like copy a file there, and it really has kind of broken the way packaging was done for decades. So I actually insist that we still do packaging correctly inside all our projects. We only ship debs, even though that may not be true for all projects. You should only ship binaries, version control using Semva, that you can apt-get install into a container, and then you ship that container. Okay? The container should have the same version as that binary. Really, really important. We would go even a step further. For those that use Docker, you probably see a lot of Docker entry shell scripts. They're really terrible. You should just have good initd scripts or systemd. Right. So Jenkins is sort of at the heart of our build pipeline, right? I'm sure you've seen this before. You can use Jenkins or any CI to talk to basically anything. For us, it is a way for us to guarantee quality when we ship to business. It runs all our static code analysis, includes PMD, Sonar, and find bugs. Sonar, not yet, actually, I shouldn't say that. And we sort of pushed it a bit further. We started running Selenium tests. Now, we have a very interesting way to run Selenium tests and also security scans. We actually use Docker Compose. So I highly recommend you guys all try this out as well. Like, you don't need to maintain a Selenium grid with a whole bunch of browsers that you may or may not work with a remote web driver. Why don't you just fire them up using Docker Compose, run your tests, and then tear them all down? Wouldn't that make a lot more sense? And in fact, it does. And it works brilliantly. We don't have Selenium clusters running anywhere. It's all on demand. Another thing that I do with the recently, a few weeks ago, was to perform all WASP ZAP scans against our APIs on every commit. And the way we do this is also with Docker Compose, that every time somebody commits something, I would do a black box scan, making sure all the security is sort of in check, at least on the black box level. So yeah, Jenkins, Docker Compose, they're your good friends. And of course, you can run performance tests, ship to production, Nexus, whatever you like. It's all very possible. What you should do is, when you do this transformation, is figure out what your build pipeline will be. Because it's not just about running tests, doing static code analysis. It could be sending out emails. It could be telling somebody. So you should go and figure out what it is. Sit down with your team, come up with a whiteboard, and come up with your pipeline. The moment you do that, you should actually test it, right? It's like writing code. Your pipeline needs to actually work. You can't just write boxes. Another thing we find in enterprises is a bunch of people drawing boxes. None of these boxes makes any sense because nobody can build it. So your build pipeline must be completely buildable. And we use Jenkins Job Builder for this. We don't ever sit around and click on Jenkins and create jobs. We have it all in YAML. So if our Jenkins falls over, we just recreate Jenkins with all the pipelines. So it's quite nice. Jenkins supports the notion of forking. So you have a job that can fire off other jobs, several other jobs. And Jenkins also supports the notion of joining. So after all the other jobs are completed, you can join and wait. And it supports timeouts and all this sort of stuff. So you can seriously go and test the pipeline without actually compiling anything. Yes, test it. Very good. Another thing you should do is use a DSL. So I mentioned we use Jenkins Job Builder so that nobody points and click. And not that we're against user interfaces or anything, but everything needs to be reproducible and repeatable and automated. So having YAML is really, really nice. Jenkins 2 has a groovy DSL, so that would work as well. Another thing you should do is to provide Vagrant Boxes or Docker containers for your team to use that can create these Jenkins setup. So you don't have to, the team don't have to fiddle. There's no sort of this scary big Jenkins setup phase, and then if you need it, you fire it up, you're done with it, you tear it down, you can test everything. At some point, you're going to have a build pipeline, and it's going to be green. You're going to be chuffed. You're going to be super thrilled. And it's a really great moment when you can go to business and go, yo, check out the green lights. We can ship. It's really, really good. But there's something else we do on top of all of this. We're just starting to do, actually, or I'm doing. I'm not sure how everyone else feels about it. But I'm starting this sort of promoting this, we should do more ChatOps. We should actually use Slack a lot more than we are today. So Jenkins is at the heart of everything, right? It is not only able to execute our pipeline and tell us when it fails through emails and Slack, you can also use that as sort of a dashboard for business to tell them like, this will be shipped then, we're doing this, and blah, 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 security scans and reports. But what's interesting is all of the notification is pushed to Slack. Granted, Jenkins has access to AWS and GitHub and a bunch of all our containers. We actually need a robot, in my opinion, to sort of perform a lot of things I want to do. And the rationale is quite simple for me anyway, is a lot of the times, some of the times maybe, like people who use a lot of terminal and commands, sysadmins, for example, it's very difficult for them to teach their secret sauce for the rest of the team. If you ask me, I much prefer to sit on a terminal, be left alone for like, 2 days, and magic would just happen. But if you can do that on a chat channel, where everybody can see exactly what you're doing and perhaps bounce questions, or sort of the other way around is you're trying to run these commands and you have a robot that can actually help you, and you can ask for help from your teammates, like, am I issuing the right commands? Should I be doing this? It's actually really productive, and it's really good. Currently, our robot only rebuilds my containers, which is quite a lot of them, and it tells me the weather. I think it says one or two things funny. So I want to use it more. I really don't know what this bunch thinks about it, but I hope they like it as well. Okay, so you have ChatOps, right? ChatOps is super cool. Now you are piecemealing your sort of micro services. You have a build pipeline, everything is repeatable. Is that enough? Are you getting a win? Can you get everything you ever dreamed of? Are you fixing the IT problem? Well, almost. In my opinion, I think the biggest ingredient in IT in general, it's actually about people. It's about culture. It's about DevOps. So the biggest part of the strategy I said 2 years ago was we actually need to change the people we recruit. We can't just recruit traditional sort of developers. We need to have full stack DevOps people that knows about Agile and all this, and perhaps different programming languages altogether. Developers that are not afraid of doing Terraform, who can jump on Kubernetes, just as much as they welcome the new Java technologies as well. And we had a name for them. I call them the Avengers, and we actually call them that in our company. We're very proud to have them. I'm really proud to have them as well, and I think they've done fabulously. But the key strategy here is you don't need 20 developers sitting on change requests. You need one superhero to do your bidding, right? So you don't need an army to fix a problem. You just need one superhero to fix your problem. That's exactly what you need. And when you have a team of them, you can do a lot. Incidentally, so this is our findings to sort of summarize our journey. For us, it's still fairly complex to deploy between the cloud native and on-premise. A lot of coordination still needed, and there is a lot of residual resources that still don't quite get what it is we're doing. Yes, you will have to face those guys. When things go wrong, monitoring can be difficult. You might have existing monitoring systems that don't really, or people in general don't know how to use Logstash, Grafana, and Kibana. You might have to deal with those problems too. And some of the monoliths, if they fail kind of silently, or the logs disappear. And it's a terrible situation, and you need to deal with them. That is also our finding. You are potentially going down a microservice landscape, right? You don't want the big ball of mud that we keep hearing about in this conference. This is true. You need to put a control on this. You may need to put it behind an API gateway. Whatever it is you need to do, you need to control your future of APIs. Last but not least, monolithic dependencies are definitely still killing us. We have your microservices is only as good as your monolith, right? And you need to fix that. That is still a problem. You need to cache data if you can. You need to replicate data if you need to. You need to figure out a clever way to do this. And of course, as you're doing this, you're going down a path of polyglot tooling, polyglot persistency. So there was a talk about like developers are choosing too many databases. I say the contrary. Go and use the different databases. Use the right tools for the right jobs. Don't be afraid to be a technologist, a creative technologist. Everyone sitting here, I believe, should be proud of what they do, and businesses actually cannot function without us. Think about that for a second. But last but not least, should we Docker everything? As soon as we're doing Kubernetes, everyone gets very excited, like, oh, can we please put our ERP system inside Docker? Can we put CRM in Docker? Can we have 2 CRMs? Can we have 3 ERPs? Can we have highly available ERPs? Well, unfortunately, the answer is no. Don't do that. It's terrible. There's things called J2EE that don't play nice in Docker that we found. You're going to get into situations you have to deal with like shared sessions between J2EE, and the way we solve that is to cough out our own code and maintain it. Your clustering is not exactly going to work out of the box. And are you going to run embedded J2EE? I don't know. Actually, just stay away from J2EE. So no, don't do that. Bad combo. So to sort of summarize, we have some time for questions, I hope. Is the enterprise dead? Or is Statoil enterprise IT dead? No, we're very much alive. This journey works. And we're here to talk about it, and I hope you really enjoyed it. But some of, just before I sort of summarize, which I've done, but I'll sort of just want to tell you what's really important in your day-to-day is all these new technologies don't solve the fact that we have shitty applications still. At some point, you need to solve them. We do have terrible ERPs. We do have terrible integration code. They don't go away until somebody actively and do a clever thing or two with them. And last but not least, believe in yourselves, and DevOps is culture. You guys can all make a difference. Thank you.